Hey guys, how's it going? Welcome to the video on factoring, on solving by factoring. So in our do now, or in our class, we started with this do now. It says how many roots does this graph show? Well, it actually just shows 2 roots. How do we know? Well, it intercepts our x-axis twice. That's how we know. We'll write 2 roots. Then it says which equation shows you the roots immediately. So if we look at the 2 equations shown on the graph, we notice that it's going to be this one, and it's also known as factored form because we realize that our graphs or our roots are x is equal to -3 and x is equal to +5. Which equation shows you the roots immediately? Okay, we just answered that one. And then we go into B, what is, or factor this quadratic. So for part B, this part of it, you guys can actually factor any method that you guys feel most comfortable with. I know there's the cross method, the box method, and some other ones out there that teachers really like to use. Whatever you guys feel comfortable with, that's okay with me. So for the sake of most people feel comfortable with this method, I'll go with the cross method. On top we put our multiplication, on bottom it's our addition. So what we multiply is always our first and last number in standard form. So in this case, a times c. When we multiply a times c, we get -15. And when the only number that remains is our b value, that means it's -2 down here. So we're looking for 2 factors of -15 that when we add, we get -2. Now for this method, I've also put a little variation or a spin on it. I like to actually create my table. Product is 15. And this last sign tells us that we're adding or subtracting. So in this case, we're subtracting. I'm going to list all my factors of 15 and then find one that when I subtract, I get 2. So 1 times 15, when I subtract, that gives me 14. 2 times doesn't work. 3 times 5, when I subtract, gives me 2. Bingo. That is the one I want. So I'm going to use those 2 values. Meaning I'm going to use 3 factors, 3 and 5. Now I got to figure out which one's going to be negative and which one's positive, because if I multiply these 2 factors, I get +15, and if I add them, I get 8. So if I make 5 negative, I'm going to get -15, and when I add them, I get -2. So we're done. So just keep in mind, guys, when we break into binomials, we have 2 binomials. They both start with x's, and all we have to do is plug in our 2 factors. So we get a +3 and a -5. And this becomes factored, and we're done. So this is our solution. Okay, so we have the title of this one is Solve by Factoring. Our objective is given an understanding of factoring. Students will generate the roots of a quadratic by factoring the quadratic equation. So that's all we're going to focus here is we're going to use the factoring method to obtain or generate roots of a quadratic function. Here's some vocabulary terms we need to know. So you guys can pause at this time and kind of write these notes in your vocab log. Monomial is a number, variable, or combination, or both. So examples of these would be a number, it can be a variable, or a combination of both. A binomial is 2 monomials separated by addition. So 3 plus x would be a binomial, x or 3x plus 2 is a binomial, or x minus 1 is a binomial. All examples. Trinomial is 3 monomials separated by addition. So that would be something like x squared plus 3x plus 1. Also looks like a quadratic, or an example that is not a quadratic would be x squared plus y squared plus z squared. A quadratic in standard form is written as ax squared plus bx plus c. So again, you guys can pause and write these vocab words in your vocab log. We're going to kind of go over the zero product property rule. I know we have already in one of our previous lessons. So in this one, we just state that if a times b is equal to 0, then we have that either a is equal to 0 or b is equal to 0. So in the case of our example of factoring, if we set this equal to 0, or this equal to 0, we have x plus 3 and x minus 5. So we have x plus 3 and x minus 5, and they're both equal to 0. So we're saying if we have this going on, in other words, this would be considered to be my a, and I'm multiplying, and this would be considered to be my b. So this means that x plus 3 is equal to 0, or x minus 5 is equal to 0. Well, if we solve, we get x is equal to negative 3 and x is equal to positive 5. So those would actually be our roots. So that's what the zero product property is telling us. It says if it is factorable, we are guaranteed at least one solution. So again, our zero product property just guarantees that if we can factor this out, we're guaranteed one solution. So let's look at example number 1. Example number 1 says find the roots by factoring. So again, feel free to factor whichever method you feel most comfortable with. For this example, I'm just going to use the cross method. For this one, my multiplication is on top, my addition on the bottom. I'm going to multiply A and C. So that's 1 times negative 36. I get negative 36 on top. My B is in the bottom. That's negative 5. When I find these factors, again, I add my own little twist to it. You guys are more than welcome to do the same. Other teachers do different things. It's all up to you. My product here is 36, and my sum, or actually I'm subtracting because of this sign here. I'm going to write sub. I'm going to state my factors of 36 and subtract them. 1 times 36, when I subtract, I get 35. 2 times, what is that, 18. When I subtract, I get 16, so that's not what I want. 3 times 12. When I subtract, I get 9. That is not what I want. 4 times 9. When I subtract, I get 5, and I find my variables. So this is my factors. These are the factors that I want. Let me just kind of fix that 4. It looks like a 9. 4 times 9. So I'm going to write those factors in, 4 and 9. Now again, if I add those, I'm going to get 13, which means I have to subtract. I make this one my negative number, so I get negative 5, and when I multiply, I get 36. I'm going to create my two binomials. Here's an x, here's an x, and then I'm going to go ahead and just put in my factors. Plus 4 minus 9, and remember this is equal to 0. So by the zero product property rule, I have that x plus 4 is equal to 0, or x minus 9 is equal to 0, giving me two roots. X is equal to negative 4 and positive 9. And those are my solutions. You can do it the same way with example 2. So example 2 has a leading coefficient. Now again, there's different variations. Do whatever feels natural and comfortable to you. That works with me. So I'm going to go ahead and write my multiplication and my addition. So my A is 3 and my C is negative 8, meaning my multiplication is negative 24. The only number that's left over is 10. I'm going to find two factors. My product is 24, that when I subtract again, I get 10. So I'm going to go 1 times 24, but when I subtract, that gives me 23. 2 times 12, when I subtract, I get 10. Oh, look at that. That's exactly what I needed. I found my two factors. I'm going to write those bad boys here, 2 and 12. One of these had to be negative, so this one is the negative this time. So when we subtract 2 from 12, we get positive 10, but when we multiply, we still get negative 24. So I'm going to go ahead and write down my binomials. This one has a leading coefficient. Now what I like to do is I write my leading coefficient down, and then I know I have an x on the other side. So if I multiply, I know that by whatever multiplying method you use, box method or FOIL or whatever, you end up with the first term being 3x squared. Cool. So now I look at the two terms here and I ask myself, which one of these two terms can be divided by 3 since we have a leading coefficient? So we cannot divide negative 2 by 3 evenly, but we can divide 12 by 3 evenly. That gives us 4. Meaning this solution is going to go on my other bracket. It's plus 4 because it's positive in my other binomial. Now the only thing I am left with is negative 2, and I'm done factoring. That's not my answer, but I'm done factoring. Remember that this is equal to 0, so I have to still find my solutions. I get 3x minus 2 is equal to 0, or x plus 4 is equal to 0. When we solve here, we get x will equal positive 2 over 3. And when we solve over here, x is equal to negative 4. Those would be my roots. And I'm done. So again, we kind of went over 3 examples in class. Feel free to try these out and ask me any questions. We went over some special factors. So the special factor we have is difference of two squares, meaning when the first term is a perfect square and the last term is a perfect square, we can actually just factor this out extremely quick. This becomes x plus 4, x minus 4. Another example would be x squared minus 144. Again, perfect squared, and then we're subtracting them. This becomes x plus 12, x minus 12. So that's all the perfect squared means. Excuse me. The next one we have is a perfect square trinomial. So this one we noticed the pattern as well. The first squared has to be, the first squared, or the first term has to be perfect squared, and the last term is a perfect squared. Well, if I take the square root of the, or if we take the square root of the first and the second term, okay, that sounds confusing. The way I check is if we take the square root of the last number and multiply it by 2, we should get the middle number. Or if we just take the roots of both the beginning and the last number, multiply those by 2, we should get the middle number. That's all it means. So here we go for this one. Square root of 3 is 9 times, square root of 9 is 3 times 2 is 6. That's correct. So this is a perfect square trinomial. Just factors out to be x plus 3 squared. Same thing here. Square root of 4 is 2. 2 times 2 is 4. Except this one has that negative in front, so we're just going to factor that out to x minus 2 squared, and we're done. For more info on these special factors, look at the video on completing the square. And the last example I want to run through is changing into standard form. So when we change into standard form, all we are doing is just evaluating these binomials or expanding these binomials, meaning we're multiplying. This means multiply and multiply. So I'm going to go ahead and start by multiplying what is in my two binomials. Again, you can use FOIL, you can use the box method, you can stack them up and multiply elementary style, or just distribute. Whatever method you feel more comfortable with is absolutely good for me. So for this one, I'm going to change it up a bit and just use the box method. I know some of you guys are real box method fans. So here we go. My first binomial is x plus 5. My second one is x minus 8. I'm just going to fill in my boxes. X times x, x squared, 5x, negative x, and then 5 times 8, or negative 8, is negative 40. Cool. I'm going to combine my like terms. This term combines with this term. So really what I'm left with is x squared minus 3x minus 40. Now I have to distribute my negative 2 to all three of these terms. My final answer in standard form is negative 2x squared plus 6x plus 80. And we're done. Alright guys, hope this video helped. Again, you can just pause and forward anytime or for any example that you choose. We had one more, but that pretty much wraps it up. Alright guys, hope this helped. See ya.